Kirchhoff's current law, or KCL, is a fundamental law which was first described by Gustav Kirchhoff in 1854. He also described Kirchhoff's voltage law. Kirchhoff's current law states that for any node in an electrical circuit, the sum of currents flowing into that node is equal to the sum of currents flowing out of that node. Simply, the sum of all currents in and out of a junction is equal to 0. This can be described by a river with a fork in it. We know from real-life experiences that the amount of water flowing into the fork is the same as the amount of water flowing out. This is shown in the diagram as F1 is the flow into the fork and F2 and F3 is the flow out. Here you can see the mathematical expressions for KCL. On the right, you can see that the total sum of current is equal to 0. On the left, you can see the equations for the diagram above. Beginning with the I1, which is flowing in towards the junction, we then add I2, which is flowing in the same direction. You then subtract I3, I4, and I5, as they are flowing the opposite way and out of the junction, and all of this is equal to 0. You can rearrange the equation, as shown below, to show all of the current into the junction is equal to all the currents out. Here is a worked example trying to find the unknown IA. We begin with the 11 amps that are flowing into the junction. We then subtract 3 amps and 4 amps and the unknown IA. As you can see from the working out below, this will show that IA is equal to 4 amps. Finally, here is a worked electrical example. We are given a simple circuit with I1 flowing into the junction and I3 and the unknown I2 flowing out. Starting with the 100 amps flowing into the junction, we then subtract 56 amps and the unknown I2. Again, with working out, this will show that I2 is equal to 44 amps. Thank you very much for listening, and don't forget to hit the subscribe button for more great electrical videos.